If you've driven outside of the desert Southwest, you've noticed there's a lot of rusted out old cars driving the roads. Well, the rust on these cars actually represents a class of reactions called oxidation reduction reactions. Now, to actually explain it, this is actually what happens when a car, or iron in this case, rusts. So, iron reacts with oxygen to form iron oxide. But more in depth, what has actually happened is that in an element's native state, such as iron or O2 in oxygen's case, their charge is zero. However, in oxidation reduction reaction, what's taking place is charge from the iron is actually being transferred to the oxygen to make this. So the oxygen and the iron start off with a charge of 0. Going into the product side, iron now has a 3+ charge and oxygen has actually a -2 charge. So in this case, iron, since it's losing electrons, it's called getting oxidized. Oxygen, since it's gaining electrons or charge, it's called being reduced. Now, the next thing is a little bit complicated, but bear with me. Since iron is being oxidized, it's basically causing oxygen to be reduced. So it's actually the reducing agent. Conversely, since oxygen is causing iron to be reduced, it's the oxidizing agent. Now, try this problem. Identify the reducing and oxidizing agent in the following reaction. Copper plus sulfur gas equals copper sulfide. When we come back, we'll actually go through this problem. All right, well, copper and sulfur are both in its elemental stage, so it actually has a 0 charge. Copper sulfate, now the copper actually has a +2 charge, and then the sulfide has a -2 charge. So copper, since it's actually losing electrons, is the oxidized, so it's the reducing agent. Sulfur, since it's gaining electrons, is being reduced, so it is actually the oxidizing agent.